so this is Professor Urbis White. We will go over properties of exponents and logarithms. Make sure you watch the videos, 2 videos before this video, before you move to this video. All right. Okay, properties, product property. I'm going to start with the exponent, and we're going to go to the logarithm. A to the m times a to the n. Something like this. 2 to the second times 2 to the third. 2 to the second is 2, 2. 2 to the third is 2, 2, 2. Total of 5. What you end up doing, add the 2 exponents. So, a to the m times a to the n is a to the m plus n. Even though there's a multiplication here, that's going to translate as an addition in there. Now, I want to derive the counterpoint of that, which is this one. Doing a quick derivation. Set m as log base a, set n as log base a of y. This is log base a of x, this is log base a of y. That means, if this is the case, that means x is a to the m, y is a to the n. So I'm going to go back to this. A to the m times a to the n. A to the m plus n. Remember, a to the m is x, a to the n is y. What does that mean? That means I can take the logs of both sides. That means log of this and log of that. Log base a of that is log base a of this. Right? Now let's look at this. Log base a of a, what does that mean? These two cancel out because of inverse property. That's going to give you m plus n. So you copy this. Log base a of xy is m plus n. What was m? M was log base a. And what's n? N is log base a of y. Do you see it? So you don't have to do this derivation each time. However, you can just kind of like remember that. When you have a to the m, a to the n, you add the exponents. When you're taking logarithm of a product, you end up adding the logarithms. Okay, let's look at this one. What happens to the quotient rule? Let's look at this. A to the m divided by a to the n. All right? What's that mean? Let's say I have 2 to the third over 2 to the second. What's that mean? 2, 2, 2, 2, 2. These 2 will go. These 2, you'll end up with 2. So that means exponent 1, which is 3 minus 2. So when you divide exponents, you're going to end up subtracting. The counterpoint of that is this. Log, all right, base of a of x over y is simply log base a of x minus log base a of y. So how can I derive this? Doing the little substitution before. Let's set m log base a of x, n log base a of y. What does that mean? X equals a to the m, y equals a to the n. All right, these two go together. So let's try to write this, a, m, a, n. So I know this is the case. Okay, and that is supposed to be a to the m, which is x, divided by a to the n, which is y. Now let's go and take this part and take the logarithms of both sides. Log base a of a mn, log base a of x over y. Watch. Log base a mn, these two will cancel out because of the inverse property. Okay, because inverse of its function is x, right? And m minus n. What was m to start with? M was this, and n was that. All right? So either memorize it or derive it on the spot. I will give you another one. So these two things that we already did. This one. All right, the product rule. And this one, the quotient rule. Okay? Product, quotient. if you memorize those two, it's going to save you a lot of headache. Let's do the power of a power. This means am to the nth power, something like that, 2 to the second to the third. It's going to end up with 2 times 3 is 2 to the 6. Do you see that? Power of a power is the powers just multiplied. The equivalent of that, log base a of x to the n, means you can pull that n in there. I'm not going to do the derivation at this point, just memorize it. And of course, the inverse property, log base a of a to the x is a to the log base a of x is x. This means f inverse of x is f of f inverse of x. And we did that in the first section, is x. So these two are very powerful. You'll get x. All right? Okay. You may see now questions that say, oh, expand this. You already have done the exponents, so let's practice with the logs. So when you have sum like this, what does that mean? There is power thing, so that goes in front of it. And since it's on top, it's going to go 3 log x. Now, YZR at the denominator, so you're dividing, and they are a product. Since it's the denominator, it's going to be negative log y. And since z is also in the denominator, that's negative log z. You can also do that in multi-steps. Does it make sense? All right, so let's do another one. Let's say like log ab squared CD. Okay? Here it is. Log A plus, because it's in the numerator, 2 log B. These are in the denominator, minus log C. Denominator minus log D. All right? If you had something in the denominator, let's say log A over B C fourth, let's put square. A is on the numerator, log A, minus 2 goes in front, minus 4 goes in front. Okay, I think you got to hang of this. They may also ask, okay, well, can you write it as a single logarithm? What does that mean? Plus and minus, that means I'm going to have x squared, that 2 goes back in there, and y, since there is a plus, now minus, that means in the denominator, z, and then there's a 3. Here we go. Okay, so you can also practice with that. All right, so this is the end of kind of manipulating things, and we are going to go and do equations next.